we're going to introduce these terms that I talked about last time, energy levels and spectral lines. And so this is important to get these concepts, and these words both begin with L. They both sound very similar, but they're very, very different. So energies are quantized. And so when light is emitted, an electron or nucleus or a molecule or an atom drops from a higher energy level to a lower energy level. So the levels are just like floors in a building. And a molecular system can be on a floor 1, floor 2, floor 3. Those are your energy levels. It's the transitions between the levels that we call spectral lines. Those show up in the spectrum. So we have these 3 spectral lines shown with these arrows. So notice how the energy levels are fixed on this y-axis. The y-axis is energy. And those levels are the solutions to the Schrodinger equation. And then it's transitions, it's jumps up or down that cause a spectrum. So when light interacts with matter, matter has these quantized energy levels, and then the light is absorbed at a particular spot, and we call that a line. So lines and levels are totally different things. Lines are always differences in energy levels. So you can write that down. Lines are always differences between 2 energy levels. And you can see that over here. Notice how when you have a short arrow, this top arrow here is pretty short. Okay, that means the energy difference between these 2 energy levels is small because you have a short arrow. That means you have a long wavelength. So you have a low energy difference, a low frequency, and a long wavelength. Those 3 things go together for this particular transition. Now look at the longest one from E3 down to E1, this really long arrow right here. So that arrow right there, look how short the wavelength is. You see that? How high frequency it is. So you have a short wavelength, a high frequency, and a high energy difference between the energy levels. So if you'll just understand this slide, a lot of this course is buried on this slide. It's just getting your mind around a big difference between energy levels means a really short wavelength, a really high frequency, huge energy difference. A little tiny energy difference, that means a really long wavelength and really low frequency. Okay. Now, if those arrows were going up, this would be absorption. The system's absorbing light, but if they're dropping down, that's emission. Light's coming out of the system.